Welcome. You've found your way to Sleepy Universe, and we're so glad you're here. Wherever you are right now, tucked into bed, lying on the couch, or resting somewhere quiet, I want you to take a slow, easy breath. In through your nose and gently out. Tonight, we're going to travel somewhere extraordinary, not in a way that requires you to move or think too hard or stay awake. In fact, the further we travel, the more relaxed you're going to feel. Tonight, we're going to drift through the Milky Way Galaxy, our home in the universe. Over the next hour or so, I'm going to share with you the most beautiful, strange, and quietly astonishing facts about the galaxy we live in. Facts about stars and clouds of gas and ancient light and the vast, peaceful darkness between it all. You don't need to remember any of it. There's no test. There's no reason to hold on tightly to anything I say. Just let the words wash over you like a gentle current of warm water, carrying you slowly, softly, towards sleep. Get comfortable now. Adjust your pillow if you need to. Pull your blanket a little closer. Take one more slow breath. And let's begin. Part 1, where we live. Let's start at the beginning. Or rather, let's start right here. You are lying on a planet called Earth. Earth is about 8,000 miles across, wide enough that if you could drive a car straight through the middle of it, the journey would take around 6 months, assuming you drove without stopping. But Earth, as remarkable as it is just one small piece of a much, much larger story. Earth orbits a star. You know that star. It's called the Sun. Our Sun is a medium-sized star, fairly ordinary by cosmic standards. But to us, it is everything. It is the source of almost all the energy that makes life on our planet possible. Without it, Earth would be a frozen, lightless rock drifting through space. The Sun sits at the center of our solar system, surrounded by 8 planets, dozens of moons, hundreds of thousands of asteroids, and countless comets that spend most of their lives far out in the cold dark, only occasionally swinging inward toward the light. And all of this, the Sun, the planets, the moons, the asteroids, the comets, all of it together is just one tiny neighborhood inside a structure so immense that our minds can barely begin to hold it. That structure is the Milky Way Galaxy, our home. The Milky Way is a galaxy, a vast collection of stars, gas, dust, and dark matter all bound together by gravity. It is enormous in a way that words struggle to fully capture. But let's try. If you could somehow shrink the entire solar system, the Sun, all the planets, everything, down to the size of a single grain of sand, the Milky Way would still be roughly the size of North America. That's how big it is. That's how small we are inside it. The Milky Way contains somewhere between 100 billion and 400 billion stars. Let that settle for a moment. If you tried to count every star in our galaxy, counting one per second without ever stopping to sleep or eat or rest, it would take you somewhere between 3,000 and 13,000 years to finish counting. 3 to 13,000 years, just to count them. And the Milky Way is just one galaxy among an estimated 2 trillion galaxies in the observable universe. 2 trillion, each one containing hundreds of billions of stars of their own. The universe is, to put it simply, almost incomprehensibly large. And sitting somewhere within our quiet corner of one of its 2 trillion galaxies is you, warm, comfortable, and drifting towards sleep. Part 2. The shape of the galaxy. Now, let's think about what the Milky Way actually looks like. If you've ever been somewhere far from city lights on a clear night, somewhere truly dark, like a countryside meadow or a mountaintop or a wide, empty beach, you may have looked up and seen a soft, pale band of light stretching across the sky. That band of light is the Milky Way. Or rather, it's what the Milky Way looks like from the inside. When we look out toward the denser parts of the galaxy's disk, it's the faint, collective glow of billions of stars too distant for our eyes to separate individually, all blurring together into one long, misty stripe across the heavens. Ancient people across many cultures noticed this glowing band and gave it names and stories. The Greeks called it Galaxias Kyklos, the Milky Circle, which is where our word galaxy comes from. Many cultures imagined it as a river, or a road, or a bridge between worlds. In a sense, they were right. It is a kind of road, a road made of stars, curving gently through the night. But what does the Milky Way look like as a whole? Since we live inside it, we can't simply step outside and take a photograph. Instead, astronomers have had to map it carefully over decades, using a variety of techniques, measuring the positions and distances of stars, tracking the movement of clouds of gas, using radio telescopes to peer through the dust that blocks ordinary light. What they've found is this: the Milky Way is a barred spiral galaxy. Picture a pinwheel, long, graceful arms curling outward from a central hub, like the arms of a spiral. Now imagine that instead of a round center, the hub is slightly elongated, like a bar across the middle. That's a barred spiral. And our galaxy has this shape. The central bar of the Milky Way stretches across roughly 27,000 light-years. From this bar, several great spiral arms unwind and curve outward, sweeping through the disk of the galaxy like the trails left by a slowly spinning cosmic dancer. Our solar system sits about 26,000 light-years from the center of the galaxy, roughly halfway out along one of these spiral arms, a region known as the Orion Arm, or sometimes the local arm. We are not at the center. We are not at the edge. We live somewhere in the quieter, more suburban regions of the galaxy, far from the bright, crowded, dangerous core. This is, in some ways, quite lucky. The center of the Milky Way is an intensely energetic and violent place, full of supernova explosions, powerful radiation, and the gravitational grip of a supermassive black hole. Out here in the Orion Arm, things are calmer. The stars are more spread out. There is space to breathe. The Milky Way's disk, the flat, spinning, spiral region where most of the stars and gas and dust lie, is about 100,000 light-years across. To cross it from one side to the other, even traveling at the speed of light, would take 100,000 years. The disk itself is relatively thin, perhaps 1,000 to 2,000 light-years thick in most places, though it bulges in the middle near the galactic core. Surrounding the disk is a much larger, more diffuse region called the galactic halo, a vast, roughly spherical cloud of older stars, ancient star clusters, and dark matter that extends far beyond the visible disk. The halo is mostly empty and dark. It holds some of the oldest stars in the universe, ancient, dim red stars that formed near the very beginning of the Milky Way's history, billions of years ago. They have been drifting quietly through the halo ever since, watching the galaxy grow around them. Part 3. The Age of the Galaxy. The Milky Way is old. Profoundly, almost unimaginably old. Current estimates place the age of our galaxy at around 13.6 billion years, nearly as old as the universe itself, which formed about 13.8 billion years ago in the Big Bang. To put that in perspective, our entire solar system, the Sun, the Earth, everything you have ever known or touched or seen, did not exist for the first 9 billion years of the Milky Way's existence. Our solar system formed only about 4.6 billion years ago. For 9 billion years before Earth was born, the Milky Way was already out there, already spinning, already growing, already filled with generations of stars that were born and lived and died before our sun ever ignited. Those early stars were different from the stars of today. The very first stars in the universe, sometimes called population 3 stars, formed from almost nothing but hydrogen and helium, the two simplest elements, created in the Big Bang. They were enormous. Some of them were hundreds of times more massive than our sun. And because of their size, they burned fast and hot and bright, and they died young. In cosmic terms, Young means a few million years. These giants blazed to life, fused their hydrogen into heavier elements, and then exploded in spectacular supernovae. In those explosions, all the heavier elements, carbon, oxygen, iron, gold, silicon, nitrogen, were forged and scattered out into space. Everything you are made of, every atom in your body, was once cooked inside a star or born in a stellar explosion. The calcium in your bones, the iron in your blood, the oxygen in your lungs, all of it came from stars that lived and died billions of years ago. You are, quite literally, made of stardust. It is perhaps one of the most beautiful facts in all of science. And on a quiet night, when you're half asleep and the world is still, it's a good thing to let yourself feel the deep, ancient connection between your body and the stars. Part 4. The stars of the Milky Way. Let's talk about the stars themselves for a while. Stars are, in the simplest terms, enormous balls of gas, mostly hydrogen, that are so massive and so dense at their cores that nuclear fusion takes place. Fusion is the process of pressing hydrogen atoms together so forcefully that they merge to form helium, releasing enormous amounts of energy in the form of light and heat. It is that light and heat, produced deep inside the star and radiating outward, that makes stars shine. Our sun is a star. It is classified as a yellow dwarf, a medium-sized, medium-temperature star at roughly the midpoint of its approximately 10 billion-year lifespan. It has been burning for about 4.6 billion years and has roughly another 5 billion years of life remaining. In stellar terms, our sun is ordinary, middle-aged, unremarkable, but of course, to us, it is everything. The Milky Way is home to stars of all different sizes, temperatures, colors, and ages. The smallest stars, called red dwarfs, are much tinier and cooler than our sun. They burn so slowly and efficiently that some of them are expected to live for trillions of years, far longer than the current age of the universe. Red dwarfs are the most common type of star in the Milky Way. The vast majority of the galaxy's hundreds of billions of stars are these small, dim, long-lived embers of nuclear fire. Most of them are invisible to the naked eye, even though the nearest star to our sun, a red dwarf called Proxima Centauri, is only about 4.2 light-years away. That's our nearest neighbor in the galaxy, and it is still completely invisible without a telescope. On the other end of the scale are the massive stars, the giants and supergiants. These are stars many times larger than our sun, burning with ferocious intensity, blazing in brilliant shades of blue and white. A star called R136A1, located in a neighboring galaxy, is estimated to be around 200 to 300 times the mass of our sun. If you placed it where the sun is, it would engulf Mercury, Venus, Earth, and Mars. Its light alone would be utterly blinding. But these massive stars pay a price for their brilliance. They burn through their fuel so quickly that their lives are short, a few million years at most. Compared to the trillion-year lifespan of a red dwarf, massive stars live like bright candles in a windstorm, burning hard, burning fast, and going out with dramatic, explosive violence. When a massive star dies, it explodes in a supernova, one of the most powerful events in the universe. In a matter of seconds, a dying star can release more energy than our sun will radiate over its entire 10 billion-year lifetime. For a brief time, a supernova can outshine an entire galaxy. After the explosion, what remains depends on the star's mass. Some supernovae leave behind a neutron star, an object so dense that a teaspoon of its material would weigh about 1 billion tons. Others collapse into something even stranger, a black hole. The Milky Way contains many neutron stars and black holes scattered throughout its disk and halo, the quiet, dark remnants of stars that lived and died long ago. Part 5. The Great Darkness, dark matter. Now, here is something wonderfully strange. When astronomers add up all the stars and gas and dust in the Milky Way, everything that we can see or detect directly, it only accounts for about 15% of the galaxy's total mass. The other 85%, the vast, overwhelming majority of what makes up our galaxy, is something we cannot see, cannot touch, and do not fully understand. We call it dark matter. Dark matter does not emit light. It does not reflect light. It does not interact with light at all, as far as we know. It passes through ordinary matter, through stars and planets and people, without effect. We can only detect it indirectly, through the gravitational influence it has on the things we can see. We know dark matter is there because of the way galaxies rotate. In the 1970s, an astronomer named Vera Rubin was studying how stars and spiral galaxies orbit their galactic centers. Based on the known mass of stars, she expected the stars near the outer edges of galaxies to orbit more slowly than stars near the center, just as the outer planets in our solar system orbit the sun more slowly than the inner ones. But that's not what she found. The outer stars were orbiting just as fast as the inner stars, sometimes faster. The only way to explain this was if there was a huge amount of additional, invisible mass spread throughout and around the galaxy, holding it together with extra gravity. That invisible mass is dark matter. The Milky Way is wrapped in a vast, invisible dark matter halo, a cloud of unknown material extending far beyond the visible galaxy, perhaps stretching out to 1,000,000 light-years or more. This dark matter halo is what holds the Milky Way together. Without it, the galaxy's stars would slowly drift apart. We don't know what dark matter is made of. It is one of the deepest mysteries in all of science. Some physicists think it might be made of undiscovered subatomic particles. Others have more exotic proposals. For now, it remains one of the universe's most enduring secrets, a vast, silent, invisible presence that surrounds us on all sides and yet passes through us without a whisper. There is something strangely peaceful about that. The universe is mostly made of something we cannot see and do not understand. And yet here we are, held gently inside it, carried along in its slow, quiet dance. Part 6. The Heart of the Galaxy, Sagittarius A*. At the very center of the Milky Way, roughly 26,000 light-years from where we orbit, there is a heart. It is not a heart made of muscle and blood, of course. It is something far stranger. At the core of our galaxy sits a supermassive black hole, one of the most extreme objects that the laws of physics allow to exist. This black hole is called Sagittarius A*, pronounced Sagittarius A*. It has a mass of about 4 million times the mass of our Sun. A black hole is a region of space where gravity has become so intense, often due to the collapse of a massive star or the merging of many stars and black holes over billions of years, that nothing, not even light, can escape once it has crossed a certain boundary called the event horizon. Beyond the event horizon, the laws of physics as we understand them break down. Space and time become so warped that our equations stop making sense. It is one of the great frontiers of human knowledge, a place where our best theories reach their limit and the universe keeps its deepest secrets. Sagittarius A* is enormous by any human measure, but for a supermassive black hole, it is actually considered relatively quiet and modest. The black holes at the centers of some other galaxies are billions of times the mass of the Sun, so active and voracious that they power what we call quasars, the brightest persistent objects in the known universe. Sagittarius A*, by comparison, is calm. It occasionally flares with activity when a cloud of gas passes too close or a star wanders into its grip, but most of the time it sits in relative silence at the center of our galaxy, a dark and massive anchor around which everything slowly turns. In 2022, astronomers working with the Event Horizon Telescope collaboration, a global network of radio telescopes working together as a single Earth-sized instrument, captured the first direct image of Sagittarius A star. It appeared as a ring of glowing orange and golden light surrounding a dark central shadow, the silhouette of the event horizon itself. It was a remarkable moment. For the first time, humanity looked directly at the dark heart of our own galaxy and saw it, truly saw it, as a real place. The image looked a little like an eye, an ancient, enormous eye, looking back at us from the center of everything. Part 7. The Spiral Arms. Let's drift outward now from the galactic center, moving gently along the sweeping curves of the spiral arms. The Milky Way has several major spiral arms, each one a long, curving region of the galaxy's disk where stars, gas, and dust are more densely concentrated. These arms are not solid structures. They're more like slow-moving waves of density that travel through the disk of the galaxy over hundreds of millions of years. Think of a busy highway. The cars themselves keep moving, but at certain points, near an exit, around a bottleneck, they bunch together, creating a region of higher density that moves slowly along the road. The spiral arms of a galaxy are something like that. Regions where star-forming material piles up as it passes through, triggering the birth of new stars, and then dispersing again afterward. The major spiral arms of the Milky Way have names. There is the Perseus arm, which curves through the outer parts of the galaxy. There is the Sagittarius, Carina arm, one of the most prominent. There is the Norma arm. And there is the Scutum, Centaurus arm, one of the two major arms of the galaxy. Our solar system lies in a smaller, partial arm, the Orion arm, also sometimes called the local arm, nestled between the Perseus arm and the Sagittarius, Carina arm. The spiral arms are the birthplaces of new stars. The gas and dust that accumulate in these regions are squeezed together by gravity, slowly collapsing into denser and denser clumps, until eventually the pressure at the center of a clump becomes high enough to ignite nuclear fusion, and a new star is born. Star formation is a slow and quiet process. It can take millions of years for a star to fully form from a collapsing cloud of gas. There is nothing dramatic about it in the short term. It is more like watching a flower open in extraordinarily slow motion, a gentle, patient gathering of matter toward a bright and burning center. Every star you have ever seen in the night sky, every single one of those points of light, was born this way, from a cold, dark cloud of gas. Gravity pulled matter together, and light was kindled. Part 8. Nebulae, the stellar nurseries. In the spiral arms of the Milky Way, scattered between the stars, are vast clouds of gas and dust called nebulae. The word nebula comes from the Latin word for cloud or mist, and that's a fitting name. From a distance, many nebulae look like glowing, softly colored clouds, gossamer and ethereal, lit from within by the young stars that are forming inside them or nearby. Some nebulae are among the most beautiful objects in the known universe. When photographed using telescopes that capture wavelengths of light beyond what our eyes can see, infrared light, ultraviolet light, they reveal structures of breathtaking complexity and color, pillars and arches and delicate tendrils of glowing gas, vast bubbles carved out by stellar winds, regions that look almost like coral reefs or forests or mountain ranges, but made entirely of gas and dust, stretching for light years. The most famous nebula visible from Earth is the Orion Nebula, a region of active star formation located roughly 1,300 light-years away in the sword of the Orion constellation. On a clear, dark night, it is just barely visible to the naked eye as a faint, fuzzy patch. Through a telescope, it becomes a glowing cloud of pink and orange light, harboring thousands of young stars in various stages of formation. The light you see from the Orion Nebula left it 1,300 years ago. When it began its journey toward your eyes, the city of Baghdad was being founded. The Tang dynasty ruled in China. The Maya were building their great cities in Mesoamerica. That light traveled all that time and all that distance to reach you. There is something deeply calming about that thought. You are a receiver of ancient light. Even lying still and quiet and half asleep, you are connected, through the simple act of looking up, to the vast, ongoing story of the cosmos. Not all nebulae are nurseries. Some are the remnants of death. When a star like our sun reaches the end of its life, it does not explode. Instead, it slowly expands into a red giant, puffing its outer layers outward in a widening sphere of gas while its hot, dense core is left behind as a white dwarf. The expanding shell of gas left over from this process is called a planetary nebula. It has nothing to do with planets. The name is historical, from early astronomers who thought these round, glowing objects resembled the disk of a planet through early telescopes. Planetary nebulae come in all kinds of shapes: rings, butterflies, hourglasses, helixes. They glow with the energy radiated by the hot white dwarf at their center, which slowly fades over billions of years. They are some of the most beautiful objects in the galaxy, and in a quiet way, they are monuments, gentle, glowing markers of a star's ending, broadcasting one last, luminous farewell into the surrounding darkness. Part 9. The rotation of the galaxy. The Milky Way is spinning. Right now, as you lie still and breathe slowly and let sleep come closer, the entire galaxy is rotating, slowly, steadily, turning like an enormous pinwheel in the deep dark of space. Our solar system, carried along in the rotation of the Milky Way's disk, is traveling at roughly 828,000 kilometers per hour around the galactic center. That is about 230 kilometers per second. This is an almost incomprehensible speed. A passenger aircraft travels at roughly 900 kilometers per hour. We are traveling at nearly 1,000 times that speed, sweeping around the core of our galaxy. And yet we feel nothing. Not a vibration, not a breeze, not the faintest hint of this motion. Because everything around us, all the stars and gas and dust in our neighborhood, is moving at roughly the same speed and in the same direction. There is no wind, no friction, no sensation. Just the silent, imperceptible sweep of our journey around the galactic center. At this speed, it takes the solar system about 225 to 250 million years to complete one full orbit around the center of the Milky Way. Astronomers call this time span a galactic year or a cosmic year. The last time our solar system was in the same position relative to the galactic center that it occupies today, the Earth was in the Triassic period. Dinosaurs were just beginning to appear. The continents were still part of the supercontinent Pangaea, slowly beginning to drift apart. In the history of Earth, there have been only about 18 to 20 galactic years. In the entire history of the universe, the Milky Way has completed perhaps 50 to 60 full rotations. We are riding something ancient and vast and slow. Part 10. Our stellar neighborhood. Let's zoom back and now, from the grand scale of the galaxy to the quieter neighborhood around our own Sunday. Within a few dozen light years of our solar system, there are a few dozen known stars. This region of space is sometimes called the local bubble, a region of lower density gas that was carved out by supernova explosions a few million years ago, leaving a relatively empty cavity in the interstellar medium. Our nearest stellar neighbor, as I mentioned earlier, is Proxima Centauri, a dim red dwarf star about 4.2 light-years away. It is part of a three-star system, along with Alpha Centauri A and Alpha Centauri B, which orbit each other at a greater distance. From Earth, Alpha Centauri A and B appear as a single bright star in the southern sky. the third brightest star visible from Earth. Their combined light has been crossing space for about 4.4 years before reaching your eyes. Proxima Centauri is interesting for another reason. It is known to host at least one planet, called Proxima Centauri b, which lies within what astronomers call the habitable zone, the range of distances from a star where liquid water could potentially exist on a planet's surface. Whether Proxima Centauri b actually has liquid water or life of any kind, we do not know. The planet is subject to intense stellar flares from its small, active star, which may make conditions quite harsh. But it is there, the nearest known potentially habitable world beyond our solar system. Even at the speed of our fastest spacecraft, a journey to Proxima Centauri would take tens of thousands of years. Our interstellar neighborhood is vast and quiet, the stars separated by distances that make even our fastest technologies feel slow and small. And yet, astronomers now believe that most stars in the Milky Way have planets. Some estimates suggest there may be more planets in our galaxy than there are stars, perhaps hundreds of billions of planets, each one a world, each one a possibility. Among all those worlds, how many harbor life? How many have oceans, or forests, or something we cannot even imagine? We do not yet know, but the sheer number of possibilities is enough to fill a quiet mind with wonder. Part 11. The light we see and the light we don't. There's something important to understand about how we see the Milky Way, and it has to do with the nature of light itself. When you look up at the night sky and see a star, you are not seeing the star as it is now. You are seeing it as it was in the past, specifically, as it was when the light you are receiving left it. Light travels at about 300,000 kilometers per second. That is fast beyond our ordinary experience. Fast enough to circle the Earth about 7.5 times in a single second. But the universe is so large that even light takes a long time to cross it. The light from our sun takes about 8 minutes to reach Earth. So when you look at the sun, you see it as it was 8 minutes ago. The sun we see could theoretically have changed in the last 8 minutes, and we would have no way of knowing yet. The nearest bright star in the night sky, Sirius, is about 8.6 light years away. The light reaching you from Sirius left that star about 8.5 years ago. The bright stars of the Big Dipper are between 80 and 125 light years away. The light you see from them left those stars somewhere between the late 1800s and the mid-1900s. The farthest stars you can see with your naked eye are thousands of light years away. When their light left them, many of the great ancient civilizations were still flourishing or hadn't yet begun. And the faint, misty glow of the Milky Way's core, that soft blur near the constellation Sagittarius, that light has been traveling for about 26,000 years. It left the galactic center when Homo sapiens were still in the Stone Age, painting pictures on cave walls and learning to navigate by those very same stars. The night sky is not a picture of the universe as it is. It is a picture of the universe as it was, a layered archive of different moments in the past, all arriving at your eyes at the same instant. You are watching history, written in light. Most of what the universe has to say, it says in light that our eyes cannot see. Visible light, the colors of the rainbow, the colors of sunsets and stars, is only a narrow slice of a much broader spectrum of electromagnetic radiation. On either side of visible light stretch wavelengths that are invisible to us: radio waves, microwaves, infrared, ultraviolet, X-rays, and gamma rays. When astronomers study the Milky Way using these other wavelengths, they see a completely different galaxy. In radio waves, the galaxy reveals its cold gas clouds. In infrared, it shows its warm dust and the stars hidden behind that dust. In X-rays, it shows regions of extreme energy, neutron stars, black holes, supernovae remnants. The Milky Way we can see with our eyes is, in a sense, just the tip of an enormous iceberg. The full galaxy, revealed in all its wavelengths, is far richer, stranger, and more complex than any single view can capture. The universe is always saying more than we can hear. Part 12. Star Clusters, Families of Stars. Stars, it turns out, are not always solitary wanderers. Many of them travel in groups. The Milky Way contains two kinds of star clusters: open clusters and globular clusters. They are quite different from each other, and they tell us different parts of the galaxy's story. Open clusters are groups of a few hundred to a few thousand stars that form together from the same cloud of gas and dust. They are found mostly in the disk of the galaxy, within the spiral arms, and they tend to be relatively young on cosmic time scales, because over millions of years, gravitational interactions and the tidal forces of the galaxy gradually pull them apart and scatter their member stars. The most famous open cluster is the Pleiades, also known as the Seven Sisters, a group of hot, blue-white stars visible to the naked eye in the constellation Taurus. They are about 440 light-years away and formed together roughly 100 million years ago. On a clear night, most people can see 6 of the Pleiades with the naked eye. The 7th is slightly too faint for most. But people with excellent vision, or eyes adapted to the dark, can sometimes spot 7 or even more. Ancient cultures around the world, from the Greeks to the Aboriginal Australians to the Pleiades, noted these stars and wove them into their stories and calendars. Globular clusters are something different altogether. A globular cluster is a tightly packed, roughly spherical collection of tens of thousands to millions of stars, all held together in a dense gravitational embrace. Unlike open clusters, which drift through the disk of the galaxy, globular clusters orbit in the galaxy's halo, tracing vast elliptical paths that carry them above and below the galactic plane. The stars in globular clusters are among the oldest in the universe. Many of them formed more than 10 billion years ago in the early life of the galaxy. The Milky Way is surrounded by about 150 known globular clusters, perhaps more. Imagine standing on a planet inside one of these clusters and looking up at the night sky. The stars would be so densely packed that the sky would be ablaze with light. Thousands of stars as bright as our brightest stars are to us, the sky never fully dark, a perpetual soft twilight of stellar light. It would be beautiful in a way that is hard to imagine from our quieter, more sparsely populated corner of the galaxy. Part 13. The Milky Way's Companions. The Milky Way does not travel alone. Our galaxy is part of a small family of galaxies called the Local Group, which contains about 54 members in total. The Local Group is held together by mutual gravity, a loose gravitational community drifting together through the larger universe. The two most prominent members of the Local Group, besides the Milky Way itself, are the Andromeda Galaxy and the Triangulum Galaxy. The Andromeda Galaxy, also known as Messier 31, or simply M31, is the largest galaxy in the Local Group. It is a spiral galaxy, like the Milky Way, and it is about 2.5 million light-years away. On a clear, dark night, it is visible to the naked eye as a faint, elongated smudge of light in the constellation Andromeda, the most distant object most people will ever see without a telescope. That faint smudge contains roughly 1 trillion stars, more than the Milky Way itself, all packed into a disk about 220,000 light-years across. And here is something remarkable. You are looking at it as it was 2.5 million years ago, when that light began its journey toward your eyes. Our ancestors were early members of the genus Homo, just beginning to make their first crude stone tools on the African savanna. And here is something remarkable, and perhaps slightly unnerving. The Milky Way and Andromeda are on a collision course. Right now, the Andromeda Galaxy is approaching us at about 110 kilometers per second. In approximately 4.5 billion years, the two galaxies will begin to collide and merge, eventually forming a single large elliptical galaxy, sometimes nicknamed Milkomeda or Milkdromeda by astronomers. Now, collision is a somewhat misleading word. When galaxies merge, the individual stars within them almost never actually collide, because the space between stars is so vast that even when two galaxies pass through each other, the stars slip past like two ghost clouds walking through each other. What does happen is gravitational disruption. Stars are thrown into new orbits. The shapes of both galaxies are dramatically distorted and torn apart, and over the course of 1 billion years or so, the two systems gradually settle into one. By the time this happens, our sun will be near the end of its life anyway. The Earth may already be uninhabitable, scorched by our aging, expanding sunday. And so the great merger of our galaxy with Andromeda may occur without anyone on Earth to watch it, or it may be witnessed by beings so different from us that we could barely imagine them. The Milky Way also has a number of smaller satellite galaxies, dwarf galaxies that orbit around our own, held in place by our galaxy's gravity. The most prominent of these are the Large and Small Magellanic Clouds, two irregular dwarf galaxies visible in the southern hemisphere's night sky. They look like detached pieces of the Milky Way, two bright, hazy patches of light hanging in the southern sky, separated from the main river of the Milky Way. The Large Magellanic Cloud is about 160,000 light-years away and contains around 30 billion stars. The Small Magellanic Cloud is about 200,000 light-years away with around 3 billion stars. Both are slowly being pulled apart by the Milky Way's gravity, streams of gas and stars trailing behind them as they orbit. In time, they too will likely merge with our galaxy, their stars absorbed into the Milky Way's vast collection, adding to its size, enriching its stellar population, continuing the slow, ancient process of galactic growth. Part 14. The Milky Way in Human History. Let us slow down for a while and think about the Milky Way not just as a scientific object, but as a presence in human experience. For nearly all of human history, before electricity, before cities, before the glow of screens and streetlights, the Milky Way was visible to every person on Earth, every clear night. Our ancestors did not see a faint, washed-out smear at the edge of their vision. They saw a brilliant, sweeping river of light, arching across the entire sky, so bright that it cast faint shadows on the ground. They saw the dust lanes, dark rifts running through the band of light, where dense clouds of interstellar dust blocked the glow of the stars behind them. This sight was so striking, so present, so unavoidable, that virtually every human culture developed stories and explanations for it. The ancient Greeks, as we mentioned, called it the Milky Circle and told a myth about the goddess Hera spilling her breast milk across the sky. In Hindu tradition, it was Akashganga, the Ganges of the sky. In Norse mythology, it was Bifrost, the rainbow bridge connecting the world of humans to the world of gods. In many Aboriginal Australian traditions, the Milky Way, including its dark patches, was read as a celestial emu, an enormous bird whose form was traced not in the stars, but in the dark lanes between them. This is a remarkable inversion of the Western tradition of finding patterns in the stars. Here, the shapes are found in the darkness between the light. In the Kalahari, the Sand People of southern Africa told stories about the Milky Way as embers and ashes, the remains of an ancient fire scattered across the sky. In parts of East Africa, it was seen as a canoe resting on the sky's river. The Chinese called it Inha, the Silver River. In Finland, it was Linnunrata, the path of the birds, because migratory birds were believed to follow its glow on their seasonal journeys. These stories are as different as the cultures that created them, and yet they all point to the same impulse: the deeply human need to look up, to notice the vast and luminous presence above us, and to say, that means something. That is part of our story. Today, more than a third of humanity lives in places so light-polluted that they cannot see the Milky Way at all. The ancient river of light has been swallowed by the glow of civilization. For billions of people, the night sky that shaped so much of human culture and imagination is simply gone. This is, in its quiet way, a kind of loss. But it is not irreversible. In dark places, the Milky Way still burns. In mountains, in deserts, in the open ocean, far from the cities, it is still there, exactly as it has always been. Unchanged, patient, waiting. Part 15. The future of the Milky Way. Let us end our journey tonight by looking forward. The Milky Way has a future as well as a past. A long, slow, majestic future stretching billions and trillions of years into the darkness ahead. In about 5 billion years, as I mentioned, our sun will reach the end of its hydrogen fuel. It will expand into a red giant, its outer layers engulfing the inner planets, before shedding those outer layers as a planetary nebula and settling into a white dwarf, a slowly cooling ember of its former self. The Milky Way, however, will continue long after the sun is gone. New stars will be born from the galaxy's remaining gas and dust. Old stars will age and die. The great slow rotation of the galaxy will continue, the spiral arms drifting and shifting over hundreds of millions of years. In about 4 to 5 billion years, the merger with Andromeda will begin, reshaping both galaxies into something new and enormous. Over the following billion years or so, this great merger will settle into a large elliptical galaxy, rounder and smoother than either of its parents, without the graceful spiral arms, but still rich with stars and history. On timescales of trillions of years, far beyond the current age of the universe, even this merged galaxy will change. Star formation will gradually slow and stop as the galaxy's gas is used up or expelled. Old stars will die and not be replaced. The galaxy will grow dark and cold, populated mostly by ancient white dwarfs slowly cooling toward black and by black holes. On even longer timescales, so long that they barely feel like real numbers, even the white dwarfs may eventually decay. The galaxy will become truly dark, but we are very, very far from that ending. The universe is only 13.8 billion years old. It has ahead of it a future many, many times longer than its past. Whatever comes, whatever forms and structures and perhaps beings arise in those unimaginable future eons, will build on the foundation that the Milky Way and galaxies like it have laid. The stars that are burning tonight are planting seeds. The heavy elements they forge in their cores, the material they scatter in their deaths. This is the raw material of future generations of stars, future planets, future possibilities. The universe is not winding down. It is still, in many ways, just beginning. Closing, drifting to sleep. We have traveled far tonight. We have floated from the earth, from this warm, quiet room where you are resting, outward through the solar system, into the spiral arms of the Milky Way. We have visited the heart of the galaxy, the ancient globular clusters, the stellar nurseries glowing with newborn light. We have looked at dark matter and distant galaxies, at the deep future and the ancient past. And now we drift back through the spiral arms, back past the billions of stars and worlds, back into our quiet neighborhood of space, back to our small yellow sun and its family of planets, back to this blue and green world, this island of life and warmth, this place where consciousness arose and looked up and asked, what is out there? Back to this room, this bed, this breath. You are a small thing in an enormous universe, but you are also an extraordinary thing, made of the atoms of ancient stars, riding a planet that orbits a star in a galaxy 100,000 light-years wide. in a universe filled with 2 trillion more galaxies, all of it turning, all of it glowing, all of it moving in patterns of astonishing complexity and beauty. You are part of all of this, connected to all of it, in ways both scientific and mysterious. And right now, you have nothing to do but rest. Let your body be heavy. Let your thoughts drift and soften, like stars seen through thin clouds. The galaxy will keep turning tonight. The stars will keep burning. The ancient light will keep traveling across the long, dark distances between suns. And somewhere in one quiet corner of one spiral arm, you will sleep, gently, peacefully, surrounded by the soft, silent presence of a universe that is, in its own strange and beautiful way, always watching over you. Good night. This has been Sleepy Universe. Sweet dreams.